In this video, we're going to look at complex numbers. So, there are some numbers that cannot be solved using real numbers alone. So, for example, x squared equal to 1, equal to negative 1. This cannot be solved using real numbers. And so we introduce the symbol I. So the symbol I is equal to root of negative 1, or I squared is equal to negative 1, like this. So I is called the imaginary number. I is called the imaginary number. Right, so now let us look at a question. So this question says solve the equation x squared minus 2x plus 2 is equal to 0. So this is one of the questions that gives us a complex number. So we have that when we solve this, we will get, using the quadratic formula, which is x is equal to negative b plus minus root of b squared minus 4ac divided by 2a. So when we work out this, what is our b? So our b is negative 2. So negative 2. So the general form of this quadratic equation is written as ax squared plus bx plus c. That's a constant equal to what? To 0. So this is the general form of a quadratic equation. So we identify our values there, our a, b, and c. So we get that our b is negative 2. Negative 2 there we can replace plus minus. Then we have what is our b squared. So there b we replace negative 2 squared minus 4. Our a is 1 in that case, and our c is 2 divided by 2 multiplied by our a, which is 1. So here we can go further on. So when we multiply negative by the negative there, by negative 2, we get positive 2. Then we have plus minus. When we square negative 2, we get positive 4. Minus negative 4 by 2, we get negative 8. So that's minus 8 there. Then divided by 2. So inside there, you get 2. So we have 2 outside, plus minus. Then you get negative 4 divided by 2. From here, what can we do? So from here, you say this is going to be equal to so plus 2 plus minus. Then here inside we can factor out that negative, or we can multiply, say, negative by 4. Right, so by root there we can separate those two there. We can separate the 2. So inside we can have negative 1 to remain alone, and we have root of 2 this. So we have negative 4, or we have 4, root of 4, then multiplied by negative 1 there, then divided by 2. So I've not changed anything since it's multiplication there. 2 plus minus the root of 2, the root of 4 is 2. Root of 4 is 2. Then from here we have our negative 1 there divided by 2. So I see that 2 there is what is common. Can you erase this top part? 2 is common. I can factor out a 2 there. Can factor out a 2. So factoring out a 2, I get that equal to 2. Then I have 1 plus minus then negative 1 there divided by 2. So this 2 can divide into the 2 there, then you have 1 plus minus negative 1. So we do not have a value for this root of a negative what value, root of a negative number like that. When you're dealing with the square root of a negative number, there's no what value there. So that's why we introduce I equal to root of negative 1, the imaginary number. So we can write that as 1 plus minus negative I. And so x is equal to 1 plus I, or x is equal to 1 minus I. So these are your two values, and we see that these are complex numbers. So now, complex numbers, these are an examples of this was an example of how we cannot always get real numbers, but we can get what complex numbers. So now, when it comes to complex numbers, the value which we have gotten has two parts. So it has two parts. It has what we call the real part and what we call the imaginary part. So here the 1 is the real part. Then the I here is the what is the imaginary part. So the 1 is the real part and I is what is the imaginary part. So complex numbers, let me erase this first. Okay, complex numbers are just a pair of these are ordered pairs a comma b, ordered pairs a comma b, where a and b are written as a plus I b, like that. Then we are saying that a is the real part, then b is the imaginary part. So this is usually the complex number is usually given a letter z. So z is equal to a plus ib, which is our complex number. Now let us look at some properties which are very useful in the study of complex numbers. So for two complex numbers to be equal, let's say I have two complex numbers, z1 equal to a plus ib and z2 being equal to c plus id. So let these be two complex numbers. So for these two complex numbers, they can only be equal if and only if a is equal to c and b is equal to d. So these can only be equal if this a is equal to what? To c there. So what do we mean? We mean that the real part must be equal to the other real part there for these two complex numbers, and also the imaginary part must be equal to the imaginary part. Then these will be equal. That's the only way that these two complex numbers can be equal. Now let us look at another property, which is addition. So when it comes to addition of complex numbers, if you have z1 being a complex number as a plus ib and z2 to be c plus id, then we have that the addition of these two complex numbers, z1 plus z2, we will add the real part is added to the other real part, and the imaginary part is added to the imaginary part, just as we would do if we're dealing with vectors component wise, if we were to say. So now this is going to be equal to so you write that there, a, so this is I plus your c plus id. then you add the real part to the real part. So meaning a is going to be a plus c, then plus here on the imaginary part you factor out the I, then you have b plus d. So this is how we add what complex numbers. Let us look at an example. So we have these two questions that are given here. So we say evaluate 4 plus I plus 3 minus 5I. That's A. How are we going to do that? So we add the real part to the real part and the imaginary part to the imaginary part. So this is going to be 4 plus 3, then you have plus your I there, you factor out the I, then you have 4, okay, you have 1, sorry. So that's supposed to be 1. You have 1 minus 5, like that. Now how are we going to add? So we just add here, so that will be 7 plus, you have I, and there in the bracket 1 minus 5 is negative 4, so that is 7 minus 4I. This is your answer. Let us do question B as well. So what are we going to do there? So we add the same way we were just adding the real part to the real part. So if you want, you can rewrite this b to be in the form 2 plus 3I. So the minus can distribute such that you have plus here minus 7 minus 4I, like that. Then you add, now the real part is 2, then for the other one it's minus 7 plus I here, you factor it out, then 3 minus 4, then you get negative 5 there plus I minus 1, and this will give you negative 5 minus I. So we have added those two complex numbers. Now let us look at the next property, which is multiplication. So when we come to multiplication, we have that. So in general, if we have two complex numbers, that is, we have a plus I, b, we're saying this is multiplying by another complex number c plus I, d, like this. So we will multiply in the same way we do it algebraically. So now that is going to be equal to, you say a, then c plus I, d, like that, plus your IB here, then you multiply by the same part here, which is c plus I, d, like that. So this is going to be equal to, so a by c, you multiply a by c, that's ac, so plus a multiplied by id, you get I a d, plus, so IB multiplying by C, you get IBC. Then you have the last one, IB multiplying by ID. So that will be I squared, since it's I multiplying by I. Then you have BD. Now, from where we started, we said that I is equal to root of negative 1, or I squared is equal to negative 1. So where there is I squared, we can what? Replace negative 1. So we have A, C here, plus I, A, D, plus I, B, C. Then I can replace negative 1 there. So this will be minus B, D. Then I can group this. I can group the real part to the real part and the imaginary part to the imaginary part. So I'll have AC minus BD, close, then I'll have plus, factoring out the I, then have AD plus BC. So this is how we multiply complex numbers. So let us look at an example. We have this question here, so how are we going to evaluate that? So we multiply, so 2 will be outside first, 2, then the whole of the second part, which is 3, okay, which is 2 plus 5I, then I close like that. Then the second part is negative 3I multiplying that, which is 2 plus 5I. So this is going to be equal to 4 plus 10I minus 6i. So that will be minus, so 3 by 5 is 15, then I by I is I squared, so that will be 15I squared. So from here we say 4 plus 10I minus 6I. So where there's I squared, I can replace there I squared with negative 1. Okay, from here I'll just say 4 plus, here I can evaluate 10 and 6I, I can subtract that, and 4I. Then negative 15 by negative 1, I'll have positive 15. So positive 15 can be added to 4, then I get 19 plus 4I. So this is how we evaluate and multiply complex numbers. Alright, let us look at another property of complex numbers. So we're looking at the conjugate now. So the conjugate of a complex number, if we have a plus ib being the complex number, then the conjugate of a plus ib is a minus ib. So the sign in between there changes. The sign that is in between changes, which the complex part, or the imaginary part of this the imaginary part of this complex number carries, the sign will change there. So we denote the complex number by z, then we denote the conjugate of this complex number by z bar. So that is how we denote that. So we can note that this, when we multiply z by z bar, we will get that a plus ib, a minus ib there. So this will be equal to a outside, then a minus ib, then I have ib, so that's plus ib, then a minus ib, then I get, this will be a squared, then a multiplying there, I have minus iab, then I have plus here to be iab, then I have minus, so that would be minus I squared, then b squared. So I squared, and then so I squared, and then b squared. Okay, so from here I can say I squared, here these subtract, so that is 0, then I squared can be replaced with negative 1, so I have negative minus negative 1, then b squared. So this gives me a squared plus b squared. So we must note that z bar is just going to be equal to this. It's going to be equal to that there. So that is a property which we must note. Now let us look at an example. So we have the conjugate. So it says find the conjugate of negative 3 plus 7i and z multiplied by z bar. So what is the conjugate of that? So what is going to change is the sign there. So it will change from positive to negative. So the conjugate, so z is equal to negative 3 plus 7i. So z bar is going to be negative 3 minus 7i. So that's the conjugate. Now we are also told to find z bar. So that will just be negative 3. So negative 3 plus 7i, then multiplied by negative 3 minus 7i. So from the previous property, this here which we did, so we will do the same. We will use that. So our a is that, our b is that. So we just multiply those, we just square those. So we will square negative 3 squared plus, then we have 7 squared, and this is going to be equal to 9 plus 4, 9, and this is equal to 58. So that's how we work out this question. Okay, so now let us look at some other properties of this conjugate. Let's look at some other properties of the conjugate. So other properties include the modulus property, so which is z. If we have z is equal to, this will be equal to, okay, before we do this, recall that z bar is equal to x squared plus y squared. Then we have modulus of z equal to root of z x squared plus y squared. So this is called the absolute modulus. So from here we can see that z bar is just equal to the modulus of z squared. So because if we square this part here, if we square this part here, it will just, this will cancel out and will just remain with x squared plus y squared, which is just this top part. So this then what will hold. Now another property we must note is if we have two complex numbers, if we have two complex numbers, that's we have z1 and z2 being two complex numbers, then the following properties are true. So we have z1 z2 bar, finding the conjugate of this. So to find the conjugate of this, you can distribute the conjugate. It's easy. You find the conjugate of z1 and find the conjugate of z2, then find the product. It will be equal to this. Also, when it comes to addition, z1 plus z2, you have a bar there, it will be the same as z1 bar plus z2 with a bar like that. And the same goes for subtraction. So that will be z1 minus z2 is going to be equal to z1 minus z2, the bar like that. And also for division, so that will be z1 divided by z2 bar, then you can distribute that. It's going to be equal to z1 here bar and z2 bar here. Okay, so you divide like that. So if you're finding the conjugate of this division here, you can just find the conjugate of z1, then you divide it by the conjugate of z2. So that's how you find that. Now we can look at an example on the modulus part, just the modulus part. So an example on the modulus part is given we have the complex number z equal to 1 minus 6i. If we have this complex number, then we are told to find this, the modulus of what, of this complex number z. So by the property, this will be, so it says a squared plus b squared, then in the what, in the root. So this is going to be, so we square x like this, a, I mean, so this is our a and this is our b. So this is our b, including that negative sign. So we square that, then plus minus 6 squared, and then you have the square root there. So this is going to be equal to 1 plus 6 squared. 6 squared is just 36. 1 plus 36 is 37. So this is just the root of 37. So this is the value that you get. Okay, now let us move on to the next property of complex numbers, which is division. So when it comes to division, if we are dividing two complex numbers, that's a plus ib divided by c plus id, what we do is we multiply the denominator and the numerator by the conjugate of the denominator. So we will multiply by the conjugate of the denominator. In this case, that is c minus id. That's what you multiply by. So what you do is a plus ib divided by c plus id. Then you multiply both the numerator and the denominator. That's id, and then c minus id. So what does that give you? So when you work out what's on top, as we have learned, we're going to just get ac plus bd plus bc minus ad. Okay, so here outside there we have the I, then divided by, since here we're multiplying the conjugate by itself, what do? We just square c and square d, then you add that. So that will be over c squared plus d squared. Right, then you can write that in the form ac. So since there's a plus sign, meaning ac is a, that means c squared plus d squared can divide into the first part, then the second part, as how I will write it, which is bd over c squared plus d squared. Then I have plus your I there, then you have b, so bc minus ad, like that, and then c squared plus d squared. So a lot of questions would ask you to leave it in this form. So that is how you work around division. So let us look at an example. So the example says, this example says, express the given number in the form a plus ib, where a, b, c are a member of the rational numbers. So what we do here is we will multiply by the conjugate of the one which is at the bottom, which is, so 5, the conjugate of 5 minus I is just 5 plus I. So we multiply by that both in the denominator and the numerator. So we have 4 plus 7i divided by 5 minus I. Then you multiply that, you have 5 plus I divided by 5 plus I. So this is going to give you, so in the top you have 4 multiplied by 5 plus I, then plus 7I multiplying by 5 plus I there. Okay, so in the bottom, since here what value is here is just 1, where I is, it's 1. So you just square. So your A is 5 and your B is I. So that should be 5 squared plus 1 squared. So let us work out what is on top there. So you have 20 plus 4 by I is 4I plus 7I plus 7I multiplied by 5 is 35I. So 35I, then I have 7I multiplied by I squared, I have 7I squared, then divided by, so 5 squared is 25 plus 1 squared is 1. Then where there's I can replace my negative. Where there's I squared, I can replace my negative 1. Then I will get that this will be negative 7. So that will be negative 7. And I have 20 minus 7. If I group, so we can add this part. 4 plus 35, I get 39. So that will be plus 39I. Then divided by, I can add the bottom, 25 plus 1, I get 26. So then what will be my final working? So 20 minus 7, I get 13 plus 39I divided by 26. So I can divide 13 divided by 26 plus 29I divided by 26, and I can simplify because 13 goes into 13 once and into 26 two times, and also there here it goes 3 and there 2 times. So that will just give me 1 over 2 plus 3 over 2I, and that is my final answer, and that's how I divide. Alright, this is how I divide. Thank you for watching.